Spent here is a minute away from writing grant proposals. So my plan is to finish up here without too much fuss and get you back to your keyboards as soon as possible. On the other two aspects of the best banquet speech, I'll get to that in just a moment. As I've approached middle age, I've gotten more and more introspective and retrospective. In particular, trying to understand a bit about what it is that motivates me as a scientist and my colleagues and friends as scientists. And a lot of people have speculated about this over the years. I've tried to reach a little bit of an understanding of it. My friend Bill Hartman, I think, has approached this many years before me. But now to the other two aspects of the best banquet speech, I can't think of anything more entertaining or informative than a dramatic reading from one of the books of Chandrasekhar. Now, this is not our old friend Radiative Transfer. This is a different Chandrasekhar, a book of essays that he published some years back called Truth and Beauty. And in particular, he was trying to understand also the motivation of scientists and wrote extensively about his ideas. But he said that he has thought a lot about this, and there are several schools of thought on the issue. I reject the view, by the way, that the motivation springs from a conscious or subconscious belief that everything he does will eventually find use in the amenities of daily life. So don't try to find reasons why planetary science is of any use. I also reject the corollary, which insists that a scientist must always consciously integrate his efforts with the social needs and urgencies of the time. But I also do not accept the view that scientists are urged on their work by a holy passion for truth or a burning curiosity to unravel the secrets of nature. I don't believe, for example, that in daily practice of his profession, the scientist has much in common with the Buddha, who renounced his princely life to contemplate the ethical and moral values which give meaning to and significance to life. And I'm afraid I am equally impatient with the idea that the scientist has much in common with Marco Polo. Well, I can't say that I've found answers to my quest for understanding why we are motivated to do what we do or choose the particular area of science or sub-area of science that we do. And so I'm really going to leave that to you. What I wanted to do tonight is to essentially show some pictures that relate to the kind of work that planetary scientists do, in particular the planetary scientists that cover the broad range of talents and experiences of the people in this room. And so I'm going to start out with some pictures that I think will necessarily cause you to think in terms of beauty and grandeur. It's fun to step back sometimes from the, oh gee, it's cool description of what we do and what we see, to recognize these enormous sweeping panoramas that we see on other worlds and that we struggle to interpret and to understand, and then pass that understanding on to the public and to our colleagues, and to find some satisfaction in it ourselves. These are all pictures that come from the kind of work that we do in planetary science. And I was turned to this particular topic by some comments that Kuiper made many, many years ago when I was an observing assistant with him at the telescope and in the laboratory sometimes. And what Kuiper showed obvious joy and even glee over was something as presumably abstract as a spectrum, in this case, of the carbon dioxide molecule. In those days, we had a spectrometer that scanned through the spectrum wavelength by wavelength, and the output was entirely analog. It came out on a chart recorder, and so we watched the pen go back and forth and back and forth. And as we came along to the envelopes that you see here of these three carbon dioxide molecules, he took a great deal of joy and pleasure in watching each rotational line slowly come out of the strip chart recorder and make the W-shaped envelopes that you see here. Well, it seems like a simple thing and abstract, but when you know what it means and you know what it's doing, and you know that there are going to be other rotational lines as you come along, then there's a great joy in that. It's reassuring. It helps bolster your feeling that physics is good, and that you might even understand a little bit of it. Kuiper told me once, by the way, and I've repeated it to myself, and others several times since that you will curse the day that you didn't learn more physics. Enough said. Similarly, at the telescope, that former picture was in the lab. Similarly, at the telescope, we were using his new spectrometer to observe the near-infrared spectra of early type stars in which hydrogen lines appear that are easily predicted in theory by the various sequences of hydrogen lines, but so far as we knew, had never been seen before in nature. And so this is a trace of an early type star, and I put red lines to denote the positions of, on the left-hand side, the Paschen series of atomic hydrogen, and that cluster on the right-hand side of the Brackett series of atomic hydrogen. And again, you know they have to be there. Watching the known come through gives you the hope that maybe something unknown will also show up. In any event, there's joy and beauty in that kind of an experience. And he passed that on subtly most of the time, but nonetheless it was very genuine. My friend and a friend of a lot of you, Dave Morrison, was present during the Viking landings on Mars. And Dave took some excellent pictures, a couple of which I'll show you here, which show some of the audience of scientists. Some of these people you'll recognize. Brad Smith, who was here for many years, Toby Owen, and then Harold Mazursky over here. Obviously in an ecstatic state. And the reason they were is because they were seeing the first pictures with any detail taken from the surface of Mars. And what a moment that must have been. And how glad I think we should be that Dave has captured some of this. Because you're really seeing into their souls, I think. Carl Sagan you can see there with Conway Lowy and others. Again, the first revelations of the detail of this other planet. Well, back to the more abstract, because there is beauty in more abstract things than just rock gardens on a distant planet. Trying to understand the nature of Jupiter's spectrum and Jupiter's atmosphere. This is the work that Toby Owen did when he was a graduate student here at LPL. And there is a picture of Toby back, I suppose, around 62, obtaining laboratory spectra that he could compare with the spectrum of Jupiter, and thereby decipher the presence of some additional methane bands, which give more information on the nature of Jupiter's atmosphere. But as I mentioned, Bill Hartman, I think, came to an appreciation for the visual in planetary science long before most of us, and with his skills and prodigious skills, I should say, as an artist, has conveyed planetary landscapes, some of which we've seen glimpses of, some of which are yet to be revealed. But I think that these kinds of pictures, which are based on the reality of the lighting and the nature of these surfaces, I think these bring a lot of pleasure to all of us. And I wanted to show you a few of those here tonight. So I'm glad you're still painting, Bill. Steve Larson gave us a new way to look at comets by a special and interesting technique that allows us to see down into the structure of the cometary coma. And this, I think, is a panorama and a beauty and a grand image as well. No one can deny the beauty and grandeur, I think, of this scene. And this is the realm of yet another one of the LPL students, Tom Jones. And what a thrill that must have been. He's spoken widely on this and passionately, and there's no trouble believing it at all when you see these images and hear him speak about it. Back to a barren and alien landscape, we have recent pictures of much more of Mars, a better understanding of the characteristics of that surface and the details of its soil, and more promise of what it might be like when we actually get to go there. We've got a few pictures here of another alien place. This is an artist's representation, as is this, but who would have ever thought that we would have these views of the surface of Titan from a very successful spacecraft that landed there very recently? And Marty Tomasco and all the people that worked with him had a key role in making all of this happen. We still don't understand that landscape and that surface very well yet, but we have the things in front of us. Well, to me, the beauty and grandeur in planetary science transcends the issue of scale. Not only do we see beauty in these vast panoramas of alien planets, but when we go to the lab and look through the microscope, we see the beauty and grandeur in the tiny and see structures in meteorites. Did I do that wrong? Anyway, again, beauty and grandeur everywhere we look. Meanwhile, back at the spectrometer, this is the kind of thing that tickles my fancy. These are spectra of Triton and Pluto, which back in the early days would have been utterly impossible to obtain, but now can be done quite easily even with modest-sized telescopes. And the beauty of this is that these wiggles up and down reveal the presence of real ices, real materials, real chemicals on alien worlds that are far, far away. Titan is another world that's been revealed in unexpectedly good detail in the data from the Cassini spacecraft over the last 6 years. The VIMS instrument, which is managed out of LPL here, has been instrumental in that. These images of Titan have been studied by a number of people, but certainly Jason Barnes and Caitlin Griffith have taken the lead in some of that work. The images also brought back from the VIMS instrument of Saturn, its atmosphere, its aurorae, I think are undeniably grand and beautiful. And my longtime friend, Bob Brown, is the manager of that, basically the inventor of the instrument, and has been keeping the team going for, in December, it'll be 20 years. So the haggard look he deserves. The volcanic surface of Io. Bob Howell is a great Io expert and has studied the thermal emission from Io and the nature of its surface. A number of these people, by the way, that I'm showing, who have come through the LPL program, have been colleagues of mine in research activities, in some cases postdocs. Bob Howell is one such person who came to the University of Hawaii, where I was, after he finished up here, and we had the pleasure of working together on a number of things. John Spencer, who is a student of all the planets and all the satellites and with all the spacecraft, is also a prodigious investigator. And also came to Hawaii as a postdoc, by the way, while I was still there. It's hard to select whom to show with the picture of asteroids because so many people work on these. These are the pictures that I either found on the website, the LPL website, or was able to pull from my other collections. Now this is really abstract, but there's beauty in this. This is the distribution of the asteroids. I don't know how many are shown here, maybe at least 50,000, I'd guess, in terms of their orbital elements and their distance from the sun. And the clustering in this diagram is indicative of the history of the asteroid belt, the history of collisions within the asteroid belt, and other things that have gone on. And this kind of a diagram reveals a lot about the history of the solar system, the details of which we are just, I think, beginning to pull out, thanks in large part to the work of Bill Botkin. Mercury, we've already heard about with Bob's interest in, from the very beginning with the Mariner 10, wasn't it? And now with the Messenger. But Mercury has attracted a number of LPL people, and more than I'm showing here. But again, these are the pictures that came to mind and that I decided to associate with this. This is kind of a vision of beauty and grandeur to come. In just under 5 years, by the way, New Horizons spacecraft is on its way to Pluto and beyond. Will Grundy and John Spencer are very much involved with this. And in 5 years' time, we will have pictures of extraordinary beauty and grandeur of the surface of Pluto and its satellites, at least one of the big satellites. Venus is another story. Those of you who saw the pictures of Dave Grinspoon with his, early pictures of Dave Grinspoon. That's him, by the way, on the lower left. And a longtime friend and colleague, Don Hunt, who is a special authority on Venus. surface of Titan revealed by radar. A whole new view, and the detection of lakes, these dark splotches that you see here. VIMS has been used, again, Bob Brown's VIMS instrument has been used to probe the nature of those lakes. Ralph Lorenz is a Titan expert with a special interest in the topography of Titan and, well, essentially everything about Titan. I especially like this picture because it's a process. It's something that's happening. This is historical geology in progress as you watch. Because minutes later, this horse skeleton was covered over by that advancing lava flow. This picture was taken in about 1970 or 71 at Kilauea volcano in Hawaii. And since then, there have been numerous other flows over the top of this. So that skeleton is preserved probably under 3 or 4 strata of basaltic lava. Someday, somebody may bore down through that, take a piece of that horse bone, do a carbon dating study of it, and date the demise of the poor animal. But it was fun to be there at the time this was happening. And I was hiking there with my friend Chuck Wood, who also had a long association with the Lunar Planetary Lab. It's also fun to look at the preserved remains of a process that you easily can understand. Here the scale is about 1 meter across, and it's a fan of Hohoe lava, again on Kilauea. And you can, in an active lava flow, you can actually watch these things form. And then they cool and freeze, and they're there as long as they last. This was a particularly beautiful and symmetric lava fan that I came across years and years ago. And I think knowing how they form, watching these kinds of things form in nature is beautiful too. Now there are some diagrams and figures in planetary astronomy that are beautiful, perhaps to only one person. The one person who tends to understand them. And in this particular case, now maybe Bill's students also understand these diagrams and his co-authors to his papers, but I'm afraid I'm not among those. Yet I appreciate that beauty is in the eyes of the beholder. Everyone seems to know. Mark Bowie has a long history of interest in Pluto and the satellites of Pluto. This is a picture I took of him and Toby Owen back when Comet Halley came through in 1976, I think, at the Mauna Kea Observatory. And we were doing spectroscopy. We never did actually publish those data, did we, Mark? But they're good spectra. There's still time, right? I'm not blaming anybody. I was just there to take the pictures. But, and then there's Ranger to the Moon. This was the third of the successful Ranger impacts on the Moon. So this was the crash of the third Ranger to the Moon in the crater Alphonsus, giving us some of the first close-up views of a very limited and fleeting section of the Moon's surface. So let me finish with this. And this is a quote from a recognized person to all of us, I think, Carl Sagan. In all the history of mankind, there will be only one generation that will be the first to explore the solar system. One generation for which, in childhood, the planets are distant and indistinct disks moving through the night sky, and for which, in old age, the planets are places, diverse new worlds in the course of exploration. And what a joy and a privilege it is to be that generation. Thank you.